So hello, let's today we're gonna do 7-2, which means similar polygons, and we need to understand what similar means. Okay, so I'm going to start the lesson with giving you an example of how similar looks like. Let's say, for example, that you have a medium cup, both of them Dr. Pepper. Well, this is equal. Okay? And if I say, well, this time I have a medium Sprite, and then I have a medium Dr. Pepper. Well, these two are going to be pretty much congruent. Even though they are not the same, but in quantity means that they are the same. Now the third sample will be, I have a large and I have a medium Dr. Pepper. Well, these are just similar. So how does it look in geometry? Well, in geometry, equal will be like having a segment AB. I can say that segment AB is equal to segment BA because it's basically it. It's just the same segment. Congruent is, for example, I have a segment XY that has 8 units, and then I have another segment MN, also 8 units. So these two are not the same segment, and they are not in the same place, in the plane, but they are congruent because their magnitude is basically the same. Similar means that if I have, for example, a triangle, and the triangle, let's call A, B, C versus triangle X, Y, Z, okay? And I say, you know what, this triangle is equilateral, and the other triangle is also equilateral. That means 60 degrees throughout all of the angles. And I say, well, this one is 8 units, all of the sides, but on the other one, it's only 4 units. Well, these two triangles are similar, okay? They have the same shape, but they are not the same side. That being explained, let's begin with the lesson by understanding that, for example, example number 1 is telling me, hey, you know what? These two triangles are similar, and this is the symbol telling me that it's similar. I don't need any image to explain to me or to show me how it is that they're similar, because order matters. And when I say order matters, I know that these are triangles and they have 3 angles, each one of these triangles. And I know, because order matters, that angle A is congruent to angle X. I will say angle B congruent to angle Y. I can say angle C congruent to angle Z. But now I can also say that segment AB that has a proportion to segment XY. And I will say that segment, let me get another color here, segment BZ has a proportion to segment YZ, and that segment AC has a proportion to segment XZ. Well, that proportion, those proportions are going to be exactly the same proportion if I were to calculate them is going to be exactly the same proportion. That is why all of them are going to be equal in proportion wise. It doesn't matter what type, if it's a triangle or any other type, of figure, quadrilaterals, pentagons, hexagons, doesn't matter. Once you establish that they are similar, there's going to be a proportion, okay? So when they do not tell you that they are similar, can you calculate the proportion? Well, let me take a look. I take a look over here, and I see, well, one marking W, one marking P. Those two angles are congruent. Two markings, congruent. Three markings, congruent. Four markings and four markings, congruent. So all these angles are congruent. So far looks good. Now I need to know, are the ratios are the same? Is the proportion the same? So you start evaluating. You go, well, let me see. WX, where is WX? WX is right here, right? WX is to PQ, 12/8. So when I simplify this, it's 3/2. Okay, so I have a proportion right there. If I can maintain that proportion throughout all the sides, compare both figures together, and they have the same proportion, then I will say that those two quadrilaterals are similar. So I look, 12 to 8 is 3/2. 8 into 12 is 3/2. 50 to 10 is 3/2. 9/6 is 3/2. So I see 3/2, 3/2, 3/2, 3/2. All of them have the same proportion. Therefore, these two quadrilaterals are similar. So when we start looking at some of the problems, and we start identifying some problems over here, we need to establish, they already told me these two are similar. So I need to list all the part of congruent angles and write the proportion, the proportion that relates to the corresponding sides for each pair of similar polygons. Well, you know what? I do not even need to look at the image. I know, and I can say super quickly, that angle D is congruent to angle G. I can say angle E congruent to angle H. And I can say angle F congruent to angle J. Because order matters. Just like that order matters, there are going to be sides in between all of these angles. So the first side that I'm going to look at is going to be side DE. And side DE is going to be compared to side GH. So I can say DE is to GH just as EF is going to be to HJ and just as DF is going to be to GJ. And we're done writing our parts of congruent angles and proportion, to the sides. So if it works like that for a triangle, it's going to work exactly the same for any other shape. So here we have a quadrilateral. I see that I have four angles. So I can just fire away because order matters. So I go PT, so I can write angle P congruent to angle T. I can say Q to U, so I will say angle Q congruent to angle U. I would say R to W. So angle R congruent to angle W. And finally, I will also say S to X, angle S congruent to angle X. Now we're going to talk about the sides. Side PQ is going to be similar, or to TU, but I'm going to make it as a fraction. So I'm going to compare. I'm going to make a proportion out of these two. So now I can say PQ is to TU just as QR is to WU. QR is to UW, just as RS is to WX, RS is to WX, and finally, just as SP or PS, doesn't matter, is to TX. Doesn't matter the shape, just the more sides, the more writing that you have to do. Now, in order for it to be similar, it needs to be the same shape, different size, but same shape. And to have the same shape, they need to have congruent angles. The angles are key here. They have to be congruent. So for number 3 is asking me, hey, determine whether each pair of figures is similar. If so, write the similarity statement and scale factor. If not, well then explain. Well, I'm gonna go over quick on 3, and I'm gonna say, well, let me take a look. I see over here all the angles are exactly congruent. I go like, all those angles are congruent. Then my next shape, all the angles must be congruent. And I look, oh, I see 2 angles are not congruent, right? So this one, it's not like that one. So it doesn't matter which one I select. I can say, well, angle L is not congruent to angle, and I can pretty much select any one of these angles. And let's say angle E, just to say one of them. Okay? Just simple, right? Well, on the other one, well, are these congruent? Are these, can I make a not congruent? Can I establish that these are similar? Well, I want you to pay attention to 2 different triangles. I want you to pay attention to the big triangle, triangle PST, and I want you to compare that triangle to the small triangle PQR. Okay? And I'm going to write here triangle PST, and I'm going to write here triangle PTS. And I'm doing this intentionally to tell you something, and I'm doing this wrong, and this is intentional. And this is the thing that I'm doing wrong. Order matters. You see, P has 1 marking for the big triangle, and for the small triangle has 1 marking. So here is P, okay? Then I selected my second angle, has 3 markings, okay? But for my small triangle, I selected the one, sorry, I used the wrong letters. Let me go over this again. These are not the ones that I should have used. I should have used R, P, R, Q. Okay. Again, it is still wrong. So you see, I put here the one with the 2 markings, and I should have put here the one with the 3 markings. So this is the thing that is wrong. Order matters. So I should have kept it the same way that I started. Okay, so now I look, 1 marking, 3 markings, 2 markings, 1 marking, 3 markings, 2 markings, 1 marking, 3 markings, 2 markings, 1 marking, 3 markings, 2 markings. Okay, so far we understand that the angles are congruent. What about the sides? Well, I don't know about the sides. I don't know what's the measurement of this side, but I know that the whole side got cut in half because these tell me that these two sides are congruent, these two. So this one has to be half of the whole thing. On the other side, I see exactly the same. This part is just half of the whole thing. While over here, I have numbers and I look, 11 is half of 22. So there's a proportion here, okay? And the proportion is half or 2/1, doesn't matter, you know, how you see it. But there is a proportion, and it's the same proportion between all the sides, and all my angles are congruent. Therefore, I can say, hey, yes, these two triangles are similar. Okay. Moving on to the back of the page. Okay. So knowing that I have proportions between the sides, if I understand that all the proportions are the same, and if they tell me that the shapes are similar, then it will be extremely simple for us to find missing values. So we take a look over here and we say, hey, each pair of polygons is similar. They are already telling me that they are similar. So therefore, I don't have to figure out if they are or not similar. I already know they are. I need to know the order because order matters. So I'm going to start over here. I'm going to say, you know what? Triangle. I'm going to say ABC. Okay. I'm going to go over here and say, well, A is in the angle with no marking. Let me find over here the angle with no marking. You know, I can just, let me use other letters here. Let's say M, and O. Okay. So I see A, no marking, so angle A is going to be congruent with angle N. So triangle, let me write here, triangle ABC similar to triangle A, no marking, N is the one with no marking, so I'm going to write here N. B, 2 markings, M, 2 markings, so I'm going to put here M. And finally, of course, it's the last one, which is going to be O. Okay, so I'm trying to find what is the value of X. X is the side in between B and A. So it's going to be the side right here in between B and A. And I'm going to compare that one to NM. So this is the side I'm going to be comparing that one to. So I can say X is to 9 just as, so I need another side. I already used 9 that have no other number here but 12. So I guess I will have to use 12. So I'm going to put 12 right here. And 12 is in between O and N. In between O and N. So I need to find what is in between the one that is, you know, related to that one, which is going to be C and A. So what is in between C and A? In between C and A, I have an 8. There it is. So now we evaluate this. We do cross multiplication. Okay. In other words, we say 12x equals 8 times 9. 72 equals 12x. X equals 6. And you're basically done with it. You found the value of X. Basically the same situation. So you're going to compare, and if you want to start writing your proportions, you know, you can say, well, here it is, X, that's the one that I want to find. X is in between 1 marking and 2 markings. So what is in between 1 marking and 2 markings? Here it is. It's right there. Now, what else do I have? I have a 10. That is the only other thing that I have. So where is the 10? The 10 is in between 1 marking and 4 markings. So right here. So now I can say, well, X is to 4.5 just as 10 is, sorry, I wrote it backwards. Just as 5 is to 10. So you do the cross multiplication, you solve for X, and for this, X equals 2.25. We're not diving into the algebra of solving this is something that we studied already before. We're going over the geometry of how it is that you need to look at the different shapes so that you can find the information and establish your equations. Again, what are we looking for? We're trying to find whatever X is. So we are trying to find this side. Well, that side is in between 1 mark and 2 marks. So what do I have in between 1 mark and 2 marks? Over here, the 24. So I can say X plus 1 is to 24, just as, okay? So what else do I have? And I try to look and see, well, I have the 18 over here. So that's the one that I will have to use. So I have to use the 12 that is in between 1 and 4 marks. So if I use 24 in the bottom, then I have to use the 18 in the bottom. 18. So what goes on top? 12. You need to solve this. And once you solve this, X equals 15. Again, we're not going over cross multiplication. We're just going over how it is that you look at the image and establish your proportions so that then you can solve for X and find the missing value. Okay. Same over here. What are you trying to find? Well, I'm trying to find X. X is in between 1 mark and 2 marks. 18 is in between 1 mark and 2 marks. So X plus 15 is to 18, just as, what is the other thing that I have? Well, I have the 30 right here. Okay, and 30 is in between 1 mark and no marks. So over here. Okay, so if I use that on top, I will have to use the 40 on top. Okay, if I use the 8 in the bottom, then I need to use the 30 at the bottom. There it is. You solve, and X equals 9. So over here, now the question is, what is the scale factor? Well, it says if ABCD similar to PQRS, find the scale factor of ABCD to PQRS and the perimeter of each polygon. All right, so let's see. So we need to find the perimeter of each polygon. We're going to take a look here, over here, and we're going to try to understand how it is that this looks. So I take a look and I say, well, I will need to find, let's begin by understanding that I'm missing a value for this side. Okay, so I will have to calculate that side. So we're going to establish something here. We're going to say 1 mark is 20. Okay. And this is going to be similar to the 1 mark over here, which is 25. Okay, so I will have to say, well, 20 is to 25 just as 14 is to x. Okay, so now we're gonna, of course, we're gonna calculate this. Let me load a calculator over here. Let me see. Let me use a simple calculator. Let me put it like, where's my calculator? Put the calculator right here on top. There it is. So a simple calculator will do. I'll move it to the side, over here, okay? And we are going to say 20x 25 times 14. So 25 times 14 equals 350. This equals 20x, right? So now we will have to divide by 20, both sides, and it's going to be 17.5. So now you know what this is. This is 17.5. So now it's kind of like extremely easy just to calculate, you know, because 17.5 plus 17.5 plus 25 plus 25. I think I did something wrong here. Let's say 25, 17.5. Okay, so 17.5 times 2 plus 50, that equals 85. So this has a perimeter of 85. Uh-oh, that's not it. It moved, sorry about this. So this is the perimeter of 85. Well, these are the one, 20 plus 20, that will be 80, and 14 plus 14, that it will be 28. So 28 plus 40 equals 68. So the perimeter over here is 68. I want you to understand something. I'm going to look at the scale factor just for a moment. And I look over here to the scale factor. If I take a look at this and I just simplify this, okay, 20 over 25, if I were to simplify, that is going to give me the scale factor. So what is the scale factor? Well, 20 over 25 can be simplified to just 4 over 5. So when I'm being asked, when I've been asked what is the scale factor, okay, over here, this scale factor is 4 over 5. And that's it. Now do your practice problems.